Hello everyone. So I'm excited to go into machine learning. Till now we were into statistics. So guys, I hope you are working on the assignments. I hope I have gone through all the four different business movements. Let me maximize this. So we had four different business movement in the previous session. If you remember guys, the central tendency. In central tendency we had mean, median and mode, and then measure of dispersion where we had variance and standard deviation. And in measure of dispersion, some people also measure range. So what does range mean? Well, range is very simple. What is range? In as per English dictionary, also range is from one point to other. In statistics, also range is maximum minus minimum. Simple. So that is your range, which also comes under second business movement, which is measure of dispersion. And then third one is measure of skewness, right, which we have already discussed. The fourth one is measure of kurtosis. So if you notice, in the first business movement, we didn't have any squares or cube. If you look at the formula, if you have gone through the previous session and then if you have gone through internet and then you have done your homework, then I believe that you must be knowing now that mean is just a power of 1, sigma x by n, right? Median, there is no power, there is no square, cube or anything. But in second business movement, the power is 2. In third business movement, the power is 3. In the fourth business movement, the power is 4. So, if you notice, this 4 business movement, I would say, are the pillars for descriptive analytics. Okay? So, I've been telling this word descriptive analytics again and again. What does this descriptive analytics mean? See, whenever you get a project, now it's very important because we are going into next step, which is machine learning algorithms. So it's very important that we should understand whenever we get a new project, there are 4 different analytics which we always look for. Okay, this is very important. The first one is descriptive analytics. The second one is diagnostic analytics. The fourth one is predictive analytics. Sorry, the first one is descriptive, second one is diagnostic, third one is predictive, and fourth one is prescriptive. Okay, so these are the 4 pillars, I would say. Whenever you get a project, you should always think on these lines. So what happens in descriptive analytics is you have to do a lot of analysis by looking at the data. Like for example, whenever you get a new data, you have to understand the data. You have to do some cleaning of the data. You have to do some statistical analysis on the data. Simple statistical analysis or exploratory data analysis, such as mean, median, variance, skewness, drawing the different plots, histogram, bar chart. We all know what is histogram, bar chart, right? So all these different graph and different analysis, what I'm talking now, comes under descriptive analytics. So what we are doing by looking at the data itself, we are trying to analyze the data. We are not doing any machine learning now on this first step. This is only descriptive analytics. Okay. So once we have the data, we are just trying to play around with the data, trying to understand the data, what's there in the data. Can we come up with some insights by looking at this data, by drawing some graphs or some statistical measures such as mean, variance. We're just trying to draw some inferences by just looking at the data. So this will be helpful when we predict in the later stage. When we go into predictive analytics, I'll tell you how this will be helpful. Okay. Now the second step is diagnostic analytics. Okay, what is diagnostic analytics? Diagnostic analytics is why we are looking at this data in first place, why we are working on this project, why there is something, what exactly for which we are solving for, what is the problem in this data, okay, why we are trying to solve this. Okay, so all these questions should appear when we are working into diagnostic analytics. Diagnostic analytics is most of verbal and thinking, so it doesn't require any coding. Descriptive analytics require coding, but diagnostic analytics is just that, trying to understand the problem. The third one is predictive analytics. Predictive analytics is where we will be going into machine learning, predictive analytics. But then, what is predictive analytics? As the name suggests, we are predicting something. Okay, so if you remember, in first step we have done descriptive analytics. We have played around with the data. When we play around with the data, that point also we can predict to some extent, but with less accuracy. But we know that we can predict by just looking at the data. For example, for the bigger data sets, it's not possible to predict just by looking at the data. So you have to play around with the data. You have to do a lot of exploratory data analysis, which is also called as abbreviated as EDA. EDA in the sense this all four business movements calculation, which we have to do in descriptive analytics. That will help us in predicting. Okay, so see, doing the predictive analytics is only like 2 or 3 lines of code. But before that, we have to do descriptive analytics, because what we are predicting in the predictive analytics, does it make sense to us? We should be able to judge that, right? And to judge that, we should be in a situation that we are playing around with the data. And that is what we do in descriptive analytics. So now in third step, we are predicting something which we will be verifying with the accuracy, and then we'll be verifying that with our inferences, what we have inferred from descriptive analytics. And then fourth one is prescriptive analytics. So in prescriptive analytics, we do lot. So we have already completed predictive analytics. We have come up with the predictions. Now in prescriptive analytics, we will give insights or recommendations to our clients that this could be better or this could not be better in your business. So these are the 4 steps. Okay. So for example, if you are looking for machine failure, if you are looking for a problem which is of machine failure, so when we do descriptive analytics, then we can look into different parameters such as the machine which is quite older than 10 years, then those machines are failing. By looking at our historical data, we understood that the machines which are 10 years old are failing. This is just an example. In the second step, diagnostic analytics. So in the first step, how did we come to know whether if the machines are 10 years old, then only it is failing? By working on a lot of descriptive analytics, playing around with the data. In the second step, diagnostic analytics, you're diagnosing. As a doctor says, we have to diagnose you, right? Similarly, why is this problem? There are some functions in the machines with the age are stopped working. That could be the reason that machine is not working. Okay, so this is like simple. The doctor diagnoses, right? We are engineers. We have to diagnose the machines, right? We have to understand the machine. In third step, which is where machine learning comes in, predictive analytics. We have to predict now. Whenever there is a new machine which comes in, so I have taken only one factor. Machine is more than 10 years old. That could be the reason it is failing. It could be a reason that machine is only 2 years old, but it is still failing because the manufacturer of that machine is not good. There are several reasons, right? And those several reasons will be handy, of all the theory which you have come up with in your descriptive analytics can be validated in your third step, which is predictive analytics. So whenever there is a new machine, you can always tell that whether this machine will fail or pass. Okay, by looking at the different parameters such as how old is the machine, who is the manufacturer of this machine, what is this machine meant for. So for example, different machines last for different time, right? For example, mobiles nowadays, mobile last for 2 or 3 years. Mobile is also a machine, right? And the cars might last for around 7 to 8 years. So depending on the different category, different machines will last for different time, right? So this is where machine learning comes in. It tells whether this machine will fail or pass. Simple. Okay. For example, whether the equipment can able to handle this thermal load or not, whether the engine can go up to this temperature, yes, like can sustain this temperature or not. So such kind of example. But then the point is, what we are doing here, the first step and the third step are interrelated. Okay. If you don't do the first step and just directly jump into third step, you will not be able to understand the business problem. Okay. And then if you're not able to understand the business problem, you cannot recommend or you cannot come up with the insights which you need to provide to your customer or to your client. In turn, you won't able to make the profit. Simple, right? So first step is important so that you can understand the data and the business problem. And then you have to go to second, third, and fourth step. I hope this makes sense to you guys. Okay. So now, what in this first problem, calculate all four business movements using pen and paper for below dataset. So this was important because the dataset was very small. I didn't ask you to calculate it over Excel or Python. Okay. I wanted you to solve it on pen and paper because so that you get used with the data. So did you all calculate all the four business movement? Oh, sorry, before going into four business movement, did you calculate mean for this?
Probability of X with the value of X.
Right. It's important. If you remember, I told the difference between mean and expected value, right? Both are one and the same, but there is a slight difference. So could you please tell me why didn't you use sigma x by n, and why did you use this formula, expected value formula?
Because earlier probability of, for example, in the case of tossing a coin,
Mm-hmm.
probability of head is equals to probability of tail.
Right.
So there is no need of like each event is having same probability.
Right.
Then you need not consider the p of x. But here 0 is having one probability, 1 is having other probability. Then so you should take weighted average of these values and their corresponding probabilities.
Right. That's the whole point. See, now you are understanding the significance. Rather than just solving the problem with respect to the formula, you're trying to understand its essence. That's more important for me. Exactly, you are right. So when there is a uniform probability distribution, what is uniform probability? That means when the probability is same for all the different random variables or for all the events, then you can directly use simple mean. Otherwise, you have to go ahead and choose for expected value, which is x into probability of the corresponding x value. So what is the value? What is the mean which you got it? Naga?
1.4.
Okay, great. So what does this expected value 1.4 means now? That means, see, 1.4 is between 1 and 2, right? And more towards 1 because it is 1.4. That means the probability of getting 0 and 1s, the probability of getting 0 and 1 is more than 2, 3, and 4 because the expected value is somewhere near to 1 and 2, but more near towards 1, right? And if you also notice the data, that also tells the same thing. The probability for 0 and 1 is more. So this is the whole point, that this is how you should validate your analysis. Now, did you all calculate whether the probability of sum of the probability was equal to 1 or not? Sum of the probability should be equal to 1, right? Then only it makes sense because these are the mutually exhaustive data, right? So the sum of the probability should be equal to 1, right? For the same event, we are trying to calculate the probabilities, right? Now, if I write 5 here, just imagine I'm writing 5 here. Below 4, I'm writing 5. Then what would be the probability? Well, for the same data set, 0, right? Exactly. The probability will be 0 because the sum of the probability should be equal to 1. Second question, what is the significance of expected value when simple mean which is already in place? I think Naga has already explained that, and I have also enlightened you guys on this, right? I've just described a few pointers on this. Third one, having skewness in the curve considered to be a bad in the analysis? Do you consider having skewness in the curve, is it bad or good? Or just guess, no? Just think and just write the answer whether it is good or bad. If you didn't work on it, just think and tell me, like, just type it, no, whether it is good or bad. Okay. In statistics, when you calculate something, you have to be very conscious when we are making a point. Okay. So in this case, having a skewness in the data is neither bad nor good. Okay. See, we always assume because we are habituated to look at the graphs which are quite beautiful. For example, in this case, when we have the symmetric graph, people say that having a symmetric curve is good and having non-symmetric curve is bad. So exactly, it's neither. It's a measure of distribution. So you should never consider a distribution whether it is good or bad. It depends on the analysis, what analysis you are working on. See, for example, for some analysis, having a skewness might be good. Okay. For some analysis, having the skewness might not be good. So it's just a measure of distribution. So for example, in this case, let's assume that selling number of cars having this distribution. For example, number of cars which are sold 1, 2, 3, 4, 5, 6, 7, and so on. So if the number of cars are getting sold which are very high at 5 and 6, which makes sense, right? There are more number of days where 5 or 6 cars are getting sold, which are more frequent, right? Selling 5 or 6 cars in a day is more frequent rather than, because it's quite obvious that no showroom can sell more than 20 cars in a single day. It's just a distribution which we have to understand. And by looking at the distribution, we should understand whether this distribution is making sense or not, right? For example, let us take in this way. Let's take this is a for high-end classes. For example, let's take this as high-end cars such as Mercedes, BMW. So selling 4 or 5 cars are more frequent rather than selling 20 cars in a day. And let's take this are low-end cars such as Maruti or maybe Alto or something. So they can actually, there are a lot of, then it makes sense that selling more of 17, 18 cars in a single day, right? So it's just a measure, it's just a different distribution, and this depends on your business problem which you are working on, right? So similarly, I've asked you guys to work on kurtosis. How kurtosis is, what does kurtosis explains? How does it help us in our analysis? So what you can do when you send the challenge sheet, when you send us the sheet for the second assignment, you can also tell us the importance of kurtosis. Okay, you can consider that as your 6th question. Now, 4th question is important, guys. You have to solve this, and there was a particular reason why I have chosen this. Okay, so guys, I'll just give you the hint for the 4th question also now. Evaluate the probabilities for continuous probability distribution with given mean as 680 and standard deviation as 31. So if you remember, guys, I have explained you z-scores in the previous session, right? Where this is our mu, this is our sigma, right? Now the value of x is 711. Then you have to calculate the z value for corresponding this x value, so that we can make sure that the mean is 0 and the standard deviation is 1. So what happens, it's clear that from here you don't have to go into z tables and calculate the probability, because first one is very simple. So for example, we have converted our normal distribution into standard normal distribution, where mean was is equal to 680 and standard deviation was 31, right? And I'm asking for the value probability for x less than 711. Let me just make it more. Yeah. So what we are doing here, it's pretty simple for this problem because x is greater than mean here, and that too how much, 31 values, right? So which is equal to 1 standard deviation. So it has to be, if suppose 1 standard deviation is here in the standard normal distribution, this is 0, this is 1 sigma, then this would be your final probability, right? This would be your answer. And we have already discussed in the previous class the probability or the data lying between -1 and +1 sigma is 68 point something, right? So this has to be 34. So this has to be 34%. And this we know this is symmetric, so this will be 50%. So 50 plus 34 is 84%, which is 0.84 probability. So the probability for x less than 711 is 0.84, right? So it's pretty simple in this case because your x value was xx was excess of mean with exactly one standard deviation, but not happens every day, right? So this was simple problem. X greater than 740, right? So for 740, you have to identify where will your 740 lie, calculate the z value with respect to 740, and then calculate the probability with respect to 740, depending on the new z score as per 740. So the probability which you will get will be on the always on the left side, lesser than, right? So once you get the probability, just do 1 minus of that probability, you will get the answer for B, probability of x greater than 740.